Hi everyone, Jill at Green Mountain Conservation Group, and today we're going to learn about polar and non-polar liquids by making fireworks in a jar. So for this experiment, you need just a minimal amount of materials. We have here just some cooking oil. It can be vegetable, canola, whatever you've got around, olive oil. We have some water. And then I'm going to add some food coloring to the oil. So I've got some greens here. We're gonna add some greens in. And so what you're gonna see is that the food coloring stays in these little balls inside of the oil. Let's see if I can add some red. I don't know if there's any more red in here to be had. One drop of red. Do some yellow. Maybe not. We could use some more food coloring. We've gone through a lot of food coloring today. Add some blue. All right, and then I'm just gonna take my trusty spoon and I'm gonna mix it all up. So this is not going to, the food coloring is not going to dissolve in the oil, and that's not what I'm trying to do. All I'm trying to do is break up the food coloring balls into smaller bits so that we really get that nice firework action. All right, so once I have my little oil and food coloring mixture, I'm going to simply pour it on top of my container of water. Got a little bit of blue bursting there. And so what we'll see over time is we'll slowly see colors. Like, I don't know if you can see that green colors bursting through there. I don't know if I can turn this. But we'll slowly see colors burst through the oil and down into the water and making a little fireworks display. So if you have, a lot of different colors in there, we're kind of, at this point of the day, relegated to blues and greens. You'll be able to get a really nice firework display. And so we're just gonna sit there and watch it. Hopefully you can see this now, all of the little droplets breaking through, and you can see the color, the food coloring is diffusing through the water in quite a lovely display. It's pretty cool to watch. It's very soothing. So why doesn't the food coloring mix with the oil? Well, that goes back to the polarity that I mentioned at the top of the video. So water is what's considered a polar liquid, while the oil is considered non-polar. And what do I mean by that? Well, let's break it down a little bit. So here's what it means to be a polar versus a non-polar liquid. So a polar liquid like water doesn't share electrons equally through its atoms. So those two hydrogen atoms can't grab electrons as well away from an oxygen atom as the oxygen can. So while overall the molecule is neutral in charge, the electrons spend far more time around the oxygen atom than they do the hydrogen atoms. Versus a non-polar liquid like oil, the electrons are shared equally through the different atoms of the molecule. So there is an overall no charge, and each of the individual atoms also don't have a charge. So oil and water is a great case of where like doesn't dissolve in like. So this is the reason oil and water don't mix, is because one, water is polar and oil is non-polar, and those two will never quite get together. So there's the second piece of play in this experiment as well. So not only are we dealing with a polar versus non-polar liquid, we're also dealing with two liquids that have different densities to them. So when our water droplet of food coloring goes into the oil, it sinks immediately to the bottom. And eventually it will start to interface with the water below, break through and diffuse the color through the water, giving you that firework pattern. So here we have another example of water is more dense than the oil. It's sinking to the bottom and then diffusing out. So not only does this experiment show you about a polar versus a non-polar liquid, it also teaches you once again about densities. thanks for tuning in. I hope you liked the experimentation station. Please feel free to write in with comments and suggestions for other video content, and we'll see you soon.